On Monday at 2 p.m. local time, more people in Florida felt ground motion from an earthquake than ever before in the state's history. And yet, this earthquake did not originate within or close to one of the least seismically active states in the country, but rather more than 300 miles away from its shoreline off the western coast of Cuba. Registering in as a magnitude 6.1, this marked the strongest earthquake to have struck any part of the Gulf of Mexico since 1959. Yet, due to its distance away from Cuba, Florida, and parts of Mexico, the ground motion caused absolutely no damage, but was felt in parts of all three countries. If I had to summarize this earthquake in one word, I'd call it odd or unusual. You see, the Gulf of Mexico really isn't all that seismically active. Most larger magnitude earthquakes that do strike in the vicinity occur to the south of Cuba at the tectonic plate boundary of the North American and Caribbean plates. Only a single earthquake was ever recorded within a 100-mile radius of Monday's earthquake, and even weirder was the earthquake's depth, which seemingly placed it at the very bottom of the local crust. However, this latter point might be incorrect because of low sensor resolution, so it might have a hypocenter of around 10 kilometers or 6.2 miles depth, rather than the stated 26 kilometers or 16.2 miles depth. And while some faults that could hold fault lines do exist nearby, along with some known fault lines, none of these intersect with the location of the earthquake which struck. So, we have an intraplate earthquake on a fault line which was likely previously unknown to science. And I think I know exactly why this rare intraplate earthquake occurred. Before I reveal why, let's first discuss the type of fault line which slipped. The moment tensor solution shows that the fault line involved in the magnitude 6.1 earthquake was a reverse fault, which is a type of fault line where the hanging wall moves upwards in regards to the footwall, generally forming in areas undergoing some form of compression. Other historical earthquakes in this segment of the Gulf of Mexico have also occurred on reverse faults, indicating a broad zone of compression, albeit a slow one, exists here. You know how I had said that there are no active plate boundaries within the Gulf of Mexico? That is true, but it wasn't always like this, and that fact can explain why Monday's earthquake happened. To explain what I mean, we need to head all the way back to the Jurassic period 200 million years ago. At the time, what is now the modern continents of North America, South America, Africa, and most of the world's landmass was joined at a single supercontinent known as Pangaea. At the time, the Gulf of Mexico did not exist yet, although a growing rift valley had slowly begun growing where it would eventually form. As Pangaea broke apart, the ever-widening Gulf of Mexico became the site of a divergent plate boundary. Specifically, a mid-ocean ridge segment today referred to as the Gulf of Mexico Extinct Spreading Center. Active between 160 million and 135 million years ago, as this spreading center created new oceanic crust, extension was applied on already existing oceanic crust nearby. This extension at times built up strain to such a degree that eventually created faults, specifically normal faults which accommodated some of this motion. I interpret that one such normal fault at least 15 kilometers long was reactivated by more modern stresses to generate the magnitude 6.1 earthquake. Yet, I said this was originally a normal fault, so why did it move like a reverse fault? Simple, a process known as tectonic inversion. This caused the motion of pre-existing fault lines to flip. This could have been caused by deposition and sliding of sediments deposited in the Gulf of Mexico, salt tectonics, the distant motion of regional plate boundaries, or a combination thereof. My point is that at least one of these processes caused tectonic inversion tens of millions of years ago at certain Gulf of Mexico faults, and this generated Monday's earthquake. Here is a U.S. Geological Survey model which suggests the chance of and number of aftershocks that might occur in multiple given time frames. As a final note, I would like to thank my new YouTube channel member, Mick E. Flip, for supporting my work.